ethanol industry has been a great place to start with the idea of using renewables to fuel our industry.
Interestingly, these two panels are made by British Petroleum. So a lot of the petroleum companies are well aware of the fact that we're reaching peak oil.
Biodiesel is a diesel substitute made from vegetable oil and alcohol.
The Clean Energy Resource Teams project, launched in 2003, connects citizens across the state with the technical resources they need to identify and implement community-scale energy efficiency and clean energy projects. A growing number of Minnesotans envision an energy future built on using energy wisely and generating energy from local renewable resources like wind, solar, biomass, and even hydrogen. The film you're about to see was created by the Central Region Clean Energy Resource Team, or CERT, to highlight some of the extraordinary energy projects happening right here in our own communities.
Hi, welcome to Hunt Utilities Group. We're really proud to have you here so you can see and understand a little bit more of what we're doing. At this point, Hunt Utilities Group is focusing in on energy alternatives. We're looking at sustainable living, which is we want to be able to use what we grow and grow what we use concept. We were looking at roots and wings because it's an old concept.
These roots are made, sculpted out of the same plaster material that's on the walls.
One day our artist was actually working on the window, and he made something that looks a lot like roots, and it's gorgeous. And I walked in and I was just marveling at it.
We feel that we're building the roots here for a new way of trying to live, which is actually an ancient way, going back to very old paths of living closer to the earth. We also want to try using some of the old technologies, which is the cob and the straw bale, and create these kind of neat houses to live in.
Cob is one of the oldest building materials ever used. Cob is a mixture of clay, straw, sand, and water. It can be used both in the dynamics of preserving thermal energy as well as have great artistic feel to it.
We want to show the world that building things out of straw and mud can actually be gorgeous.
The works that you see here were created by Peter Anderson. He demonstrated how elegant cob can be made. Our campus is probably different from any campus that you'll visit, at least in the state of Minnesota, where we're looking at energy, we're looking at environmental housing, we're looking at being able to live and sustain our lifestyle close to the earth, but we're also an education facility, we're a business incubator. And the design behind this is to try and bring people to our campus who have a shared interest. Our business incubation, for example, is specifically set up so that those who are interested in solar, wind, thermal, or even food production in an organic manner would have a place that they could come to and work with us and learn from us.
We want to prove to the industry and the rest of the world how it works. And of course, we want to know that ourselves. So we've installed hundreds of sensors, moisture sensors and temperature sensors.
This building is actually a research lab. Every aspect of this building is something that we're studying. We're studying the performance of the cob, the performance of the straw. We have hundreds of monitors throughout the entire building monitoring airflow, air temperature, humidity, and the key reason is that we want to be able to build homes that are highly efficient but also very elegant. And so in the environment that we're in right now, we have the ability to track temperatures 24 hours a day, 7 days a week, and we can access that and control it on the web.
I think a house should heat itself. It shouldn't be a huge sink to suck up all your dollars.
This building is designed in such a way that we've got 3 foot by 3 foot by 8 foot straw bale structure. So it gives us an R value of 100. The ceiling has an R value of 100. In the standard home, you generally have 6 to 12 inch walls and an R value of maybe 20 to 30. But the way that we designed the building, the awning sets out 7 feet.
The overhang on the south side of the building is very important. In the summer, when the sun is high and overhead, it blocks the sun from the windows. In the summer, or in the winter, when the sun is low and to the south, it shines in all the windows, allowing us to collect as much heat as possible.
So we can capture optimum solar energy, passive solar energy, in the wintertime, and yet in the summer, the shade casts perfectly right at the foot of the building. So the design of it was very deliberate to capture every bit of solar that we can. The other element that we did that I think is very important is we created a heat sink. The heat sink was designed before we put up any of the walls, and it's trenched air that takes the air from the top of the building, brings it down into the ground, so we are capturing all of the warm air that circulates around.
The way the building is designed, the warm air heated by the bodies, the electricity used in the building, and the sun coming in the windows rises up to the point up at the top. What we do then is we take the hot air, pull it off the top, down along the windows, and under the floor. We have a series of air channels under the floor, 2 feet down. And that allows us to heat up not only the concrete on the floor, but the earth underneath that to a height of 2 feet or 4 feet, depending on how much warmth there is. And that allows us to store the heat when the sun shines and make use of it when it's a cloudy day.
We put a perimeter of 8 feet of foam around the outside so that we wouldn't have any frost creep. And that, we found last winter, worked very well. Part of our campus mission is to find different ways that we're able to sustain ourselves without being on the grid, and yet desire to be on the grid, in part so that we can be selling power back to utilities rather than just taking it from utilities. So in an environment where you've got zero net consumption, you want to be on the grid. You want to be part of that energy flow, but you want to be able to go both ways. You want to draw energy when you need to, but also sell energy back to the utility when it needs it, when you have the capacity.
We want to find ways of being able to train people to use these kind of things that we come up with, and that becomes the educational aspect of it.
That without advertising or really having anything to sell, we have buses of people coming in, senior citizens, high school students, who just want to learn what we're doing, see what we're doing, experience the feel of cob in their hand, and have an opportunity to understand how this might impact, people's lives going forward.
It's important for us to create a destination point here where all of the people that have questions can come. They can see these types of projects in place. They can see solar being used. They can see the wind mills if we get them in place. They can see cob houses. They can get the feel of them, because without feeling it and seeing it, you don't really understand the difference. And that's what we want to bring about, is that you can actually see it, feel it, learn about the technologies, learn about the concepts, and actually begin to put them into use yourself.
I'm Kerry Nixon, the General Manager of Central Minnesota Ethanol in Little Falls, Minnesota. Our facility is in the process of adding a gasification system that will allow us to comply with US EPA, MPCA, and Department of Justice consent decree that we signed, that we would comply with new air permits that were issued this last year. For Central Minnesota Ethanol to do this would have meant that we added a thermal oxidizer, which would have cost initially a large investment for CMEC, but the biggest challenge there was operating this thermal oxidizer with natural gas. And over the last few years, the cost of natural gas has continued to rise, and we just didn't want to comply with the consent decree without challenging what technology we'd use to get into compliance, and to see if we could lower our manufacturing costs. The real challenge has been the cost of natural gas has quadrupled over the last few years. And with the demand for natural gas, it just didn't seem generally right for us to continue to stay with natural gas. The ethanol industry itself has been under the microscope for how much fossil fuels we use to manufacture a renewable fuel in the first place. So this will be our way of improving the energy balance at Central Minnesota Ethanol. So with the help of Sebesta Engineering Company and mostly Cecil Massey from the Twin Cities, we have decided to put in a gasification technology which will gasify wood waste. This wood waste will allow us to manufacture a synthesis gas that will be burned and totally replace natural gas.
As our objective in working with Central Minnesota Ethanol was to meet their needs to reduce their cost, achieve compliance, and protect their shareholder equity. We chose to do that with a technology that gasifies wood chip to produce essentially a substitute form of natural gas. That gas is then used in a thermal oxidizer to achieve destruction of the VOCs and achieve compliance for the plant on its air permit, while also reducing the cost of operation significantly. There are other benefits, though, that come from using renewable energy to run our ethanol plants. First of all, it eliminates the discussion about whether or not ethanol is truly a renewable fuel. The energy ratio on this plant will be at least 3 to 1 by the time we're done. We'll generate nearly a third of the electricity that we need to run this plant, and we will generate all of the thermal energy that we need to run this plant from the wood chips that we bring in. The effect of that is that we will have eliminated the use of natural gas in the production of ethanol at this plant. This back here is the source of the whole problem. This is the distiller's grains dryer, which the vent or the stack gas from this was what was causing a VOC emissions problem for the plant. When the plant is built and the gasification is complete, you can see the plume off the top of the column. That will disappear. Those brown tanks rising in the back are the new distiller's grain storage. And those are a replacement for the existing distiller's grain storage. A large conical vessel behind me is the gasifier. This is a prime energy design. The principle on which it works is that a small amount of air is fed into the gasifier along with the wood chips, causing the wood chips to partially burn, but not completely. That makes a gas called synthesis gas, which then can be used as a substitute for natural gas in the process of the thermal oxidizer and in steam production.
The wood waste that we'll be using is, we worked with the DNR, state DNR, and various departments in investigating what fuel source that we could use, and we settled on wood waste. And so we have had a lot of help from various departments in the state of Minnesota to investigate what fuel source we'll use.
The ethanol industry has been a great place to start with the idea of using renewables to fuel our industry, primarily because it has already access to other renewable supplies such as the distiller's grains and corn stalks. But other industries could benefit from this as well, and we encourage people who are in the process industries to look at ways that they could use their low-value co-products as a replacement for natural gas. The ripple effects that come from using renewable energy that is domestically based in Minnesota include, first of all, simply the creation of jobs to carry out that work, but it also assures us that our industry will remain cost competitive over the long term against both foreign and domestic competitors.
I think all industry and communities and so forth should look at alternative sources of energy. I think the demand for natural gas and so forth is continuing to create real stress on a lot of industries. So between solar and wind and biomass and so forth, I think there's a tremendous challenge and tremendous opportunity for communities and various businesses to utilize what's available naturally from our earth.
My name is Jason Edens, and I work for a nonprofit organization called the Rural Renewable Energy Alliance. And our nonprofit is dedicated to making renewable energy accessible to people of all income levels. And the way we do that primarily is through our solar assistance program, which is solar heat for low-income households, households that qualify for fuel assistance. There are two systems on the home. There's a solar forced air system, which basically heats the household air. So you can have a very cold winter day. It can be 0 degrees or -20, but if the sun is shining, you're going to get a tremendous amount of heat out of the system. In fact, this particular system will provide 6,500 BTUs per hour when it's 0 degrees Fahrenheit. So it's very effective. There's no pollution, there's no emissions whatsoever. And then the other system on this home is a small standalone solar electric system, a photovoltaic system. It's going to be about 250 watts, and it'll provide all of their electrical needs. So these are the two solar electric panels for their home. And interestingly, these two panels are made by British Petroleum. So a lot of the petroleum companies are well aware of the fact that we're reaching peak oil, and henceforth there'll be less and less oil production across the globe. But essentially, these guys produce DC electricity, and it is then, of course, sent into the home. And if they have DC loads in the home, they can use the DC power directly, which is efficient because you don't have to convert it into AC. But the actual production of electricity is simpler than one might think. It looks, almost magical. How does this happen? How is this able to produce electricity from the sun? But the metals that are used to actually make the cells are photoreactive, and the electrons in the outer shells of the atoms are excited when exposed to the sun, and they're basically released, and as that happens, you basically capture that release into a circuit. We have installed the solar heating system, which is on the south side of the house. It's not quite done yet, but we're getting there. It's a really simple system. There's basically a black metal with a special paint on it. As it passes across that absorber plate, the air is heated, and it can heat up to 20 degrees Celsius as it moves across that panel. And then it re-enters the house, and this air is circulated over the course of the day. And a system of this size will probably provide anywhere from 25 to 60% of their winter heating needs, which is very substantial, especially with soaring fuel costs. This is a clean and inexpensive way to accomplish the heating needs. And we're also working on a solar electric system. This is the balance of system of the solar electric system.
Here is the main shut-off for everything. On. This will be the charge control. It adjusts how much of the solar panels goes into the batteries, which is going to be in this box right here. And this is just a junction where all the wires get together, and here's a regular panel just like in everybody's house, only it's going to be DC instead of AC. DC is direct current, like in a flashlight or a car battery, and AC is alternating current, like a blow dryer. And this is the inverter. If they do want a little AC, they can plug in regular appliances into there.
There's basically two different types of solar systems. There's a solar electric system and a solar heat system. And then from those two divisions, you can further divide. A solar electric system is usually one of two types. It's either a battery-based standalone system like this system, or it's a grid interactive system, which is where there's no batteries, and all of the power that you produce is sent directly into the grid after you've used whatever you're using at the time. And there's lots of state rebates right now for grid interactive systems. In fact, the state will give you $2,000 per kilowatt that you install. And a lot of the utilities are matching that. Minnesota Power matches that, and a lot of the co-ops are matching that as well now. So there's a tremendous amount of incentives right now for grid interactive solar systems. And there are also some new federal income tax incentives for solar electric and solar heat systems. Now, as far as solar heating systems are concerned, there's a hot air system like this one, which is a very simple, low-cost system. And then there's also a solar hot water system, where rather than air flowing through the collectors, you actually have a heat transfer fluid. And you can heat your domestic water. You can also do space heating. A lot of people are tying these systems into in-floor heat systems, so you can store the heat in the slab. So there's many ways to employ these systems, depending on your site and that type of thing. And we basically sell renewable energy systems to homes and businesses, and we do so on a sliding income scale. And we sell these systems to help us finance our solar assistance program. Because every year the state of Minnesota spends literally tens of millions of dollars on fuel assistance. And fuel assistance simply pays a low-income family's heating bills, families who struggle to pay for their heat essentially. The state will step in and pay their heating bills. And it's a very expensive Band-Aid, but it doesn't provide a long-term solution. Whereas our solar assistance program actually does, because it gives them the equipment to provide for their own heat. It empowers the families, it provides self-reliance, and it does all those things with a clean technology rather than a fuel subsidy, which is essentially what fuel assistance is. As I said earlier, we are a nonprofit, and our primary program is one of charity, and so we're always seeking people to help support our work. And by this time next year, we will have an additional 20 solar assistance jobs done, and they'll be all across central and north central Minnesota. And we hope to do this all across the Midwest too. I will say that we're not yet adequately funded. The people who are on payroll receive a very, very meager stipend. We get a lot of funding from the Initiative Foundation. We get funding from the University of Minnesota Central Region Partnership. We've also worked with the Clean Energy Resource Teams. They've been very generous as well. But we, as I said earlier, we're always continuing to look for people to help support our work. It's very important work. And using a clean technology to help the lower income families who are struggling to heat their homes is a very appropriate technology.
My name is Jay Idzorik, and I live in Ironton, Minnesota with my wife Jody, and we started making some biodiesel in our garage a few years ago and collecting some used restaurant oil and processing that into biodiesel, which we used in our little Volkswagen pickup and also in our excavating equipment. And after doing that for a couple of years, we decided that we might take this commercial, so that's what we've done. And combined with Ryan Hunt, and we're off and running trying to get a biodiesel plant put together here. So,
biodiesel is a diesel substitute made from vegetable oil and alcohol. You get more than 3 times as much energy out of it as what it takes to farm it, grow it, and move the soybeans and crush them and move the oil. In tank 1, we mix the methanol, the catalyst, and the vegetable oil, and the reaction happens there. The glycerin settles out to the bottom. The biodiesel is then pumped into tank 2, where the methanol is extracted from it, the excess unreacted methanol. And then in tank 3, it's washed with water to carry out any other contaminants. And then it goes out to the product tanks outside.
Yes, you can use biodiesel in your personal vehicle or in a commercial vehicle.
You can tell a vehicle burning biodiesel by the smell. It smells not quite like French fries as opposed to normal diesel, which you will choke and sputter on.
There are no modifications required other than older vehicles that have older rubber components may be susceptible to some breakdown because of the solvent effects of the methanol, which is a part of the biodiesel.
The emissions from biodiesel are much cleaner than petroleum diesel.
Biodiesel is run or incorporated into petroleum diesel at different ratios. In the state of Minnesota, we have what's called the B2 mandate, which says that 2% of the diesel fuel that's sold in this state is biodiesel, the other 98% being petroleum diesel. Some stations sell up to a B10 to a B20 mixture. One of the considerations with biodiesel is that the gelling point, or the point at which it begins to cloud or thicken, is about 38 degrees Fahrenheit, and so it has to be dealt with accordingly. Either the vehicle has to be kept warm in a garage overnight, or it has to be, the fuel has to be cut with #1 petroleum diesel fuel. Most petroleum diesel fuel that's sold at a gas station in the wintertime is like a 50-50 blend of number 2 petroleum and 50% number 1 petroleum. So we treat biodiesel basically the same way.
One of the things that we have to consider with using soybean oil or vegetable oil is that we need to, it starts to gel as it gets colder in the winter, and so what we've done with our 12,000 gallon storage tank here behind me, the white one, is we've insulated it with 5 inches of foam shell, and then we have a copper heat coil inside of it so that we can keep the viscosity of the oil thin enough to bring it into the building. And then also with the yellow tank directly behind me is an insulated tank for our product, for our finished biodiesel. Once again, we don't want it to get so cold that it starts to gel before we mix it with petroleum.
Being a small commercial producer, we're a lot smaller than the next producer in Minnesota. We hope to sell as much biodiesel as we can locally, and that most of that we want to sell here, actually at our plant, at a retail pump. This is the tank for a retail sales pump. This bright yellow tank is easily visible on the main street here in town, and it's reminiscent of a portable yellow diesel tank. Otherwise, we're going to be providing fleets around the area, such as the landfill. They run a lot of diesel equipment, school bus companies and things like that. What you see behind me, we have a truck loading area. We have the bulk tanks that handle the inputs to the process. In the environmental rules require us to have containment for 110% containment for the largest tank we have, and so we've done that to prevent any spills. Behind here, the big red tanks, one of them's going to hold the methanol, another one's going to hold number 1 diesel to cut it with, and the other inputs are in other tanks. Our first goal is to produce 800 gallons a day, and we hope to be doing that within a month before the end of 2005. A large part of this project is using local recycled materials. The office we see behind us was in a garage that was about to be torn down. We moved it here and insulated it. The tanks you see here are all second-hand. Some of them are refurbished. And we insulated them. The tanks that we're doing the process in the other building came second-hand. Biodiesel is made from oil seeds grown in the U.S., grown locally even, and so biodiesel really helps the local economy.
By relying more on community-scale renewable energy and energy efficiency, communities can protect natural resources and create local economic development opportunities. People everywhere want strong communities, good jobs, and secure, clean, reliable energy. Central Region CERT members hope that this film will inspire viewers to join their regional clean energy resource team, and they hope that it has provided good information and context for the clean energy projects and leaders within their communities. Finally, they hope that this film inspires viewers to begin clean energy projects in their own homes, businesses, schools, churches, and communities. Together, we can help shape Minnesota's clean energy future.